Hey folks, some of you have been really waiting for this video, my take on the Jenna Bekoff effect. You may have seen these videos online. One of the greatest channels ever, Veritasium, covered it back in September. And although he wove an elegant explanation of geophysical non-application, meaning that this would not make the Earth flip over, the questions coming into us have nevertheless been overwhelming in the context of our claiming that there is a cyclical crustal disruption to Earth of some sort. Now in this video, we will review the correct mechanistic actors for a crustal disruption, and we will question whether this Jenna Bekoff effect is really what we are seeing in some of the other purported applications. Now let's start with Veritasium, one of my favorite channels ever, and their examination of this effect being caused by the intermediate axis theorem, or tennis racket theorem, where the momentum and inertial instabilities in the structure cause it to twist about the intermediate axis of the object. And here is the first question. Are these really the same thing? Try this with a racket, or a hammer, or anything else, and while being careful not to break your toes or your face, notice that the object never stops its rotation, whereas the space station spinning T does have periods of stability punctuated by a complete flip and instantaneous recapture of the stability for several more turns. This appears to be a similar, but not completely matching phenomenon. Then, we have his mathematically perfect examination of an oversimplified situation. If the Earth were an uninfluenced sphere spinning in space, our spinning about a third axis would give comfort, but that is simply not the case. First, Earth is not a sphere. It is bulged at the equator, a place where you cannot ignore the effect of that centrifugal force. And we are not spinning alone, but we orbit a star and are flanked by a moon so entwined it controls the oceans, at least for now. Now, while the angular momentum is not constant in the system, this is largely negligible. And the same may even be said for the ever-changing orbits. This year we are 1.5 centimeters further from the Sun than we were last year. But the same cannot really be said for the other variabilities. Earth does not orbit at the solar equator, but goes 7 degrees north and 7 degrees south of the solar equator, reaching those peaks just before the equinox period. At those times, the Earth transitions from going one way vertically to the other, and at that hinge point is moving vertically at zero rate, presenting the lowest points of that vertical stress from this annual variation, even if we are the most off from being at the solar equator. Let's also look at the equinox in this way. During this time, we are most tilt misaligned with the Sun, about which the Earth orbits, and it is also the time when that tilt relative to the Sun is changing the fastest. Alternatively, one need only look at the solstice and find that this is when that vertical motion peaks in speed, the one that hits zero when we are 7 degrees north and 7 degrees south, changing the other direction. Even if our tilt relative to the Sun is changing less quickly, and we are more aligned with the Sun's tilt, it is still a significant period, and each of these present different kinds of stress on the planet. The solstice periods are also very close to the closest and furthest points of Earth's orbit to the Sun, perihelion and aphelion respectively. Earth, indeed, is closest to the Sun in January, only by a bit. But even that only by a bit is not constant and not always the case. Earth's near-perfect circle of orbit becomes even less perfect over time in a cycle, and our tilt relative to the Sun in given seasons changes too. People always seem to forget about the apsidal precession that does accompany the axial precession, and just when you thought we couldn't differentiate the Earth situation any further, indeed, the fluid-filled contained third axis stability used to claim the Earth will not tip over is not the same thing as the tennis racket theorem, and modeling the Earth in this way is a massive mistake. It was just earlier this year we got updates on the large-scale structure beneath our feet. Yes, there is lots of liquid rock, but connecting the core to the upper layers are massive, pluming structures that reside within the swirling magma and maintain their structure as they do so. This takes us 10 times further from being able to model the Earth as a liquid-filled sphere, as does something like the equatorial bulge, and they also begin to cut at the real issues of crustal displacement, not the least of which being, the tennis racket theorem is not what we believe is doing the damage. Just imagine what happens when a geomagnetic induction from a superflare takes these pathways to the core. What about cosmic ray absorption in the mantle, affecting flows around them, and perhaps the stability of the structures themselves? In a superflare or micronova, the core induction is not impossible, given that the common solar storms we know today can already touch the mantle. Changes in flow, or, God forbid, the breaking of the large-scale structure beneath our feet, would be but one factor in that instance contributing to the mantle heaving, vertical land displacement both directions, plate collisions, and the ancient descriptions of earth-fire breakthroughs in the cataclysm. And that core induction, that brings up another point, because something is going on with the Earth that we just don't fully understand. The length of a day is considered fairly constant, and for the most part it is, but there are meticulously detected and confirmed length of day glitches, slight anomalies in our rotation in the length of the day, that seem to self-correct and have only been minor thus far in the time of modern science. There are both longer-term and short-term anomaly glitches in the length of day, and the long-term ones are wholly tied to changes in the geodynamo, Earth's magnetic field. The short, unpredictable ones come from either major geomagnetic storms from solar activity or from a geomagnetic jerk within Earth's core, and here's where things get interesting. Let's come back to the fact that Earth's field has begun an accelerated change already. It's looking like another excursion, same as Gothenburg, Mono Lake, Lake Mungo, or Le Champ. And when you scale up a solar blast to where the induction takes a path to the core, then you could have a solar-induced geomagnetic core jerk during the greatest of geomagnetic storms from that same solar activity. And we can only guess as to the scaling up of the rotation glitch to which Earth would be subject. Now remember, the Sun should have the largest bulge in the solar system, but it has virtually none. There is also something going on up there that we just don't see yet. And remember further, it is our primary position that, during such a blast, the loss of thermoelectric equilibrium at the low velocity zone, which unlocks the crust from the mantle, combines with that mantle's heaving, and then the plate collisions, causing the oceans to leave their beds. But alas, the length of day glitches and solar structure mystery are something that we can't ignore in the situation. The intermediate axis theorem is not the same as the fluid-filled spinner example and could actually apply to Earth in reality when you don't oversimplify and actually consider its internal structure and orbital and tilt dynamics. The main point, this flipping is not exactly what we had in mind for the crustal displacement. But when you look at the facts, the attempts to debunk Earth's displacement simply don't pass strict scrutiny of the methodology. When you add in the mysteries of the Sun and Earth's rotation glitches, and with the Sun's Hallstatt cycle up again this century, probably its 12,000-year cycle as well, and with Earth's magnetic field beginning to shift already, place your bets where you want. So have we. For more on what vexed Einstein before he died, what Major White discovered in the Arctic, what modern technological advances have told us about the Earth and Sun, and what the CIA tried to cover up, watch Cosmic Disaster right here on YouTube. Find the link below the video, and tune in daily for updates on the Sun, Earth, and related science information. Eyes open, no fear. Be safe, everyone.